Hello, welcome everyone to this presentation. This is another video on probability distribution and in particular normal distribution. So under normal distribution, we want to see how we can determine the percentage of cases, all right, below a given scale or a reference point, right? Below, that is less than, right? Less than a given number, less than a given reference point. Okay. So we'll do that by looking at an example, a question. We're saying 1,000 bulbs with a mean life at 120 days installed in a new factory, right? And their length of life is normally distributed, follows a normal distribution with a standard deviation of 20 days, all right? The standard deviation of 20 days. How many bulbs expire in less than 90 days from the 1,000 bulbs? Now, since we are talking about these bulbs being manufactured in such a manner that they follow a normal distribution. So you need to know that we are dealing with a normal distribution here, one. All right, we're dealing with a normal distribution. And because of that, we are going to apply the formula Z is equal to, that is before we even use the table. Z is equal to X minus mu divided by standard deviation, where X is equal to number 90 days. We're saying how many will expire in less than 90 days, so X is 90. Our mu is 120 because they're saying it has a mean life of 120 days. So this is the 120. And our standard deviation is 20 days. So this implies that our Z is equal to 90 degrees, and 90 so 3 minus 120 divided by 20 itself. What does this give us? It gives us negative 30 divided by 20. This is negative 3 divided by 2, and this will give us negative 1.5 sigma. So now, we are supposed to find this negative 1.5 sigma using the table, the actual value, all right? Okay, so allow me to get a table. Okay. Yeah, let me get a table. Okay, good. Okay, where is my the table? Okay. I'll not pick it in advance, just pick it. Pick it. All right, I think we are good to go. Okay. So for that drill, okay. So we want negative 0.5. So what we can do is, maybe before we even get the actual value, we can try to draw our normal curve, all right? So try to draw a normal curve. So here, that's where our mu is, which is this 0 sigma. Then it will curve here. Equal curve there. Okay. Yeah. All right, maybe much better. So now we can say this is plus 1 sigma plus 2 sigma, then plus 3 sigma. Then we have negative 1 sigma, negative 2 sigma, and negative 3 sigma. So now our 1.5, is somewhere here. So this is where our 1.5 is. Negative 1.5 is here. Here, take note, at that point, we have negative 1.5 sigma. Now, according to the question, we're interested in the number of bulbs that will expire in less than 90 days. So meaning that We are saying less than 90 days here. Here, we're interested in this part, right? So how do we handle this? You know that from the 0 sigma, from mu, on this side, this represents 50%. Then from this point, on that point, also represents 50%. So what we can do is to find the number of cases that will expire in less than 90 days, we can find the percentage between 0 sigma and negative 1.5 here. Then thereafter you subtract from 50%. When you subtract from 50%, whatever percentage you're going to get, you multiply it by 1,000. Because we're talking about the 1,000 bulbs. Okay, so we are saying this implies that we can say the total percentage that lies between 0 sigma and negative 1.5 sigma is, so we can come to our area here and check for 1.5. Okay, this is where 1.5 is. This is where 1.5 is, this one, right? So we'll get 0.4332, 0.4332. So 0.4332, which implies that this is 43.32% in terms of percentage, right? Now, how about below this now? All right. So, you can say the total percentage that that represents the number of bulbs which expires in less than 90 days is, so you know that in this yellow color here, we have got 43.32%. All right? This. But we want now from here going downwards. So it will be 50%. It will be 50% minus 43.32%. What does it mean? So this will give us 6.680%. This is the percentage of the bulbs that will expire in less than 90 days. But now the question is, how many bulbs? We want the actual number, all right? We want the actual number. So meaning that so now, therefore, the number of bulbs which will expire or which expires in less than 90 days, please 6.68% times the total number of bulbs, which is 1,000. All right. You can say this implies that you have a 6.68 divided by divided by 100 times 1,000, right? And this will give us, so give us 66.8 bulb. All right. Now we can give an approximate value. So approximately, then hence approximately 67 bulbs will expire in less than 90 days. And that's what they want. From the 1,000, about 60 bulbs expire in less than 90 days. And that's why we end for this presentation. Thank you. Continue subscribing. And as well, subscribe to our new channel, Phil Kamban JM. All right. And contact us for lessons, grade 10, 12, 8, 9, GCE at only 500 kwacha. We also provide individualized lessons, and contact us on 0978 76. Mr. Piri, 0979 73809, Mr. Bondo. Till next time, this has been Phil Kamban. Bye-bye. Shalom, shalom.